Welcome back. In this session, we're going to be looking at factoring by grouping. Problems we're going to be looked at are mainly groups of 4 terms, which are generally 2 groups of 2 terms. If in each group of 2 you can identify a common factor, then you want to go ahead and remove that. So with x plus 1, there is no common factor, but there is always a 1 as a common factor, and we'll see that. With this, there is the y as a common factor. So among those 2, I'm going to pull out the y. Here it is. Now, x plus 1, 1 plus x, they are both the same, correct? So I can reshuffle that around to read it a little neater, okay? Mainly x plus 1. Now, you should be able to see that x plus 1 is in both groups. So it is common. It is a common binomial factor. So therefore, it can be removed. X plus 1 will multiply itself to give, x plus 1 will multiply by 1 to give itself, and then by y to give this. So the common binomial factor is now removed, okay? Common binomial factor, it still suggests that we have a common factor. The common binomial factor is the x plus 1. X plus 1 will multiply y, giving you this. X plus 1 will multiply 1, giving you this. Okay? So that is the procedure we're going to use when factoring by grouping. We'll look at a couple more examples. Okay? Here. Okay? A little not at all like the other problem in terms of its appearance, but clearly both terms, if we clearly identify 2 groupings, and both have the 5x minus 2. So that's common, and it can be removed, okay? And here it is removed. So is it factored completely? Not really, because we have some terms that can be linked together here, mainly x and 3x and the 2 and the 8. So we'll we'll go through that and link those terms together, and then we are all but done. We are done. Okay. The thing you don't want to do is make this a more complicated by multiplying those out. Okay. Remember, what are we doing? We're factoring. If we're factoring, okay, factor. Keep in mind what is the objective. The objective is to get it into factors, that is terms that multiply each other, okay? So, don't be tempted to multiply these out and make life more difficult for yourself, okay? Now, here's an interesting one, okay? Now, this is x minus 1, and this is 1 minus x. Are they the same? No. Gee, wouldn't it be nice if that were, okay, if that were 1 minus x, if it were x minus 1? Well, I can essentially, okay, make that x minus 1 at the expense of a negative 1 pulled out, okay? So if I make that, okay, x minus 1 into a, if I make that 1 minus x into a negative x plus 1, and we're going to see how I can fake this machine out to do that, okay, then I can proceed with that and solve that by a common factor approach, okay? So here we go. Again, the idea, gee, why can't I just see x minus 1 at the expense of making that negative? Lo and behold, that's what it does. Now, common factor right there before your eyes, x minus 1. Okay? Remove the common factor. Remove the common factor. Finished? No, because here, difference of squares. All right? Finished now? That's it. Fully factored. Ready to go. Okay? Same protocol is going to happen here, isn't it? That 5 minus x is going to become x minus 5. Follow through on the same rationale as you did with that one. Oh, common factor here. Lots of common factors, right? X plus 7, that's common. Lowest power squared. Okay. What else? Well, they both have the X. Lowest power is cubed. So we've got common factor coming out of that nicely. And then we just got to tidy this up with a little bit of algebra and be done with it. Okay. So let's just ask that to auto step that. And then that should do it. Although it did see, it just reshuffled the terms, not for any particular reason. That's fine. Here's one of those grouping, okay? In this one, we say, well, let's see. What's common here? There's an X common here. If that's removed, let's see what happens when the X is removed from the first two, okay? So we remove the X from the first two. And then let's see, in the second two, there's a 3 that's common. So we'll remove that. And guess what? What do we have? A common factor, common binomial factor of what? X minus 2. Common to X plus 3. So we just order that the factor. And there we are. Factor completely. Somebody might have said, well, why didn't we just connect those two terms? Probably would have been easier if we had saw that. We were conditioned to look at the factoring by grouping, so let's go back and just check that and see if we get the same thing. So, I think this sees that obviously and then combines it and then just factors that accordingly. So either way, you get the same thing, okay? What about this guy? Go back. What about this guy? Okay. Well, this is X minus 3. I know that if I, let's see, is there a common factor here? In as much as this is going to be a little tricky, okay? What they chose to do here, maybe a rare occasion where that's the case, whereas when you expand that out, things come down to a little simpler approach. The X squares drop out and you're right down to that. So that did collapse that right away, okay? It's a little misleading at first, but a little foresight into that might help, okay? There you go. Okay, proceeding, common factors, well, yeah, but you might have to reshuffle the terms, so we're back at this. We say, well, look, there's no common factor with these two. There's no common factor with these two, but, there's a y in this and a y in that, okay? And then these inner two have a 3, so they might, if we could just shuffle the terms around, here we go, we shuffled the terms around, okay? And clearly now, and that should not be a problem, shuffling those terms around. You can see how that collapses to that. We can now identify that there's, within the first two, okay, a common factor of X squared. So we'll remove that. Now, you'll say, well, what about this? Well, actually, in this grouping, there is a common factor of -1. So take a look at it from that perspective. We'll pull out the -1, and now you have the y plus 3 and the y and the 3 plus y, which are the same commutative property, okay? So now we're going to pull that out as a common factor. And look at this, y plus 3 times x squared, that gives you that term. Y plus 3 times -1 gives you that term. What do you got here? Got a difference of squares, okay? Take care of it. Factor it again. Be done. Factor as much as possible. Complete. Whenever instructions and problems say factor completely, that's how you got to proceed with it. Do one or two more. Let's see where it takes us, okay? Here, again, this maybe hopefully getting the hang of it. Here, these first two in that grouping, the common factor of 5 will give you the x minus 8, but you'll say, whoa, I wish I'd said x minus 8. Well, again, if you take those as a group and pull out the negative 1 factor, okay, then that's what it will do. Okay, so take that as a group, pull out the negative 1 factor, and then you can proceed with it from there. So that should be enough problems to get you going, and see how you do with those problems, and we'll take on some of those problems in class.